So, this time round, here's the plan. Oh, it's week 83, dingus. I didn't overwrite that. No. Oh, that's interesting. Fine. Yep. Week 83. Okay. Come on, boy. Come on. Wake up. It's only Sunday. Can you solve... Right. Quad this is week 83 of the Perl Weekly Challenge. Here are the problems. Ooh, added new... I should check out the Raku reviews. Right. Anyway. So, string, 3 or more words. Find the length of the string except for the first and last words, ignoring white space. Hopefully there'll be some examples to clarify that. But it sounds like just summing up the number of word characters in the string, having chopped off the first and last ones, one way or another. Okay. An array, sounding good. Flip the sign of some members so that the sum of all the members. Flip the sign of some members of the given array so that the sum of all the members is minimum non-negative. Yeah, okay. Again, examples. I will help me. Numero uno. The string thing. So my intuition is to go for the weekly challenge, except for the first and last words. So, and it's assuming this words are separated by spaces, although we can do some stuff to make that a bit more general. And then you can drop the first and the last off, and then you can count the number of non-nested characters. Okay? And if the purpose of our lives is to be happy, then it's 23. So that's like the basic way you do that in a straightforward sense. But considering the problem, it's a little inefficient. So what you could also do, I mean, it's not bad, but the problem is you're allocating a pointer to a whole other nested array for every single word, when all you actually want to do is chop off the first and last ones. So space equals is definitely still the right place to start. Or if you don't want to do space equals is the place to be. But if you don't want to be confined to that, use membership, and you can add all of the punctuation and stuff, that you might be interested in removing as well. Oh, member swap, right. So then you just want the first one, really. You just want to split on the first one. So you could do pick where. You can drop by that many, and then do the same on the reverse. So you can do that thing catenated with its reverse. Then pick where rank 1. Is it separated by that? Yeah, well, where rank 1 you want to. So you want to pick a top where rank 1. So now 4 and 6. But it's 6. But the second one should be subtracted from, let's see, from the length, basically. So we're going to do 0, count, omega. Gonna have to make this a defen, unfortunately, just to make working with the stuff easier. Minus that. So now it's, and then get the absolute value. So it's 4 and 33. So, oh no, wait, you could do it with these two numbers, I think. The annoying thing is that once you chop the 4 off, then it's 2. So it's, god dang. So the first number, drop alpha, and then from there you want to do neg1 minus, neg2 minus slash omega, drop that. Why Are you for real? Oh, sorry, it's 6 from the end. So it is actually just minus slash. I guess it's the other way around, huh? You do a 4 drop. Oh, and then a -6 drop. Oh, okay, don't worry about being all complicated like that. The minus slash. Yeah, exactly, right? Purpose of our lives is to be. Then you just want to get rid of the spaces and count the number. So, the quick solution was quick, did this exact problem. This version is basically just a little bit more general because we're using membership. We'll look at doing regex in a second just to see. It's probably not. So my thinking was it would be more efficient to just chop the first and last bits off. And I think this might be more efficient on really, really long strings. So if we take a lorem ipsum or something, can I have it really long? I don't care. Okay. Sure. Okay, and then you're gonna go ipsum gets that. So text in. Ipsum gets 10,000 reshape ipsum. Are we allowed to do that? So it's long text now. So what we can do is just for the comparison, we can do what's the problem called? Words length. Words length simple is, let's make it defen because it's easier. And words length 2. I should have just numbered them. I don't know why I called that one S. I think this one's kind of the most straightforward. Words length 2 is all of this craziness, but actually stick the whole thing in a defen like that. And maybe for completeness, we can look into the regex one. So I'm basically thinking non-word characters replace with nothing. Yeah? Okay, no, we can do this in a single regex, I think. So we've got the beginning of the phrase. Let's go back to our example. We have the beginning of the phrase followed by one or more word characters, right? Or we just have non-word characters. But before that one, we want to do word characters, one or more, followed by the end. So, yep. So in APL, you can do multiple regexes in a single shlabam like this. And I basically did what I said. You know, word at the beginning, word at the end, word. This stuff came from Perl, and it's really, well, there's a reason everyone adopted it. It is gibberish at first, but it is a very effective way to edit natural language text stuff. So then you just count that. You get 23. So that's probably what the Perly one that's supposed to be quite quick is. And since that's on the top anyway, we can just assign it as is number 3. Words length 3. That guy. So now we can compare them. Words length, okay, hold on. We got lipsum and we have, I don't know, purpose. This guy, right? So now we can compare, words length purpose, words length 2 purpose, and words length 3 purpose. Okay, let's see what it says. Let's turn my print width up. But you get the idea. So basically the first one is nice and simple, and therefore isn't doing that much computation. The second one, although my motivation was both generalizing it and a potential speed up for really large strings, obviously it's doing a lot more computation, it's a lot longer expression, so it's about twice as slow. Is that right? Plus 100%. Although looking at the numbers, it looks worse than that. And then the regex one is fairly straightforward and simple, basically translating the problem into regex. but the PCRE engine is slow, so that's the only thing there. Next, we wanted to try it with the large one. Okay, I'd hope I didn't get a value error. Lipsum. Lipsum. Well, I don't know how, if this one will take loads longer or anything. Ha ha ha! Damn it. Okay. What do you think the deal is there? It ends in a space. That's gonna be a big one for the last two, I think. And the fact that Lipsum has punctuation in it, which means my first solution is not correct for that case. Right, so that's all that is, you know? Now I'm curious, I think it's just full stops that I saw in the Lipsum. I wasn't paying that much attention. Ah, damn. So what's the difference? Well, let's see. 100 take Lipsum. Okay, that's not nearly enough. Let's just look at probably quite large. Oh my god, it's all on mine as well. That's fine. It's got comma. I don't know if I put comma in there. It's got comma and full stop, and I forgot to put comma in this function, number 2. No commas in there. Does it end? Yeah, it ends with a space. So maybe if we get rid of that. Well, that's the halfway house, right? I mean, this one, modified to use membership, would probably give the same result. Should we call it? Sure. Okay, let's repurpose S for that. So now he's in question mark dot and space, and it's not member swap. Okay. And I think that these two will now give the same answer. Damn it. Is it the space at the end, or what is it? What? And again, with no punctuation, of course they'll work. I'm not sure. I will come back to that for the in prep for the summary video. I don't know. How bored of looking at it. To make sure these are all saved for now, I don't know. Let's start with this. Short and sweet. More general, faster and longer. Longer strings. And yeah, well, that top regex and not a word character. That omega, let's call it regex. Those are my 3 approaches. Those are my 3 approaches. I'll see what to do with them later. Okay, let's move on. Flip array. An array of positive numbers implies not 0. Flip the sign of some members of the array so that the sum of all members is minimum non-negative. Such that the resultant, yeah, so you sum them up as close to 0 as possible, but non-negative. Return the minimum number of elements, just return the number of elements. This is another search space problem essentially, I think, you know. 3, 10, 8. Basically, flip the sign of some of the elements. So, to my mind, that's things like, say, we have, okay, flip none of them. Flip the first one. Flip the second one. You know? Flip the third one. Okay? And so you can just multiply rank 1. And that's the result of all of those, and then you can sum all those, and you're basically looking for the index of the smallest one. And, okay, we'd actually pop this into here, and use it to pull from, well, nothing really. Oh yeah, to pull from there and find out how many -1s are in that expression. In fact, I'll just write that. It's the sum. The index of the smallest, and it's alpha picked by that, and it's how many -1s are there, and that's the solution. That works. That's really general. The only thing left basically is to compute all combinations of -1, 1, and 1 of the length of omega. Sorry about that. And for that I'll be using a familiar trick if you watched these videos, you've got the length of omega 2 base power neg 1 iota neg 1 plus iota the count. Oh, not quite. 2 base power. Oh, sorry, iota 2 to the power of tally omega neg 1 plus. Right, there we go. So there's all the length 3 Boolean numbers. And then my idea is that this therefore dictates. Essentially, we just want this, but with negative ones instead of the zeros. So I think we can actually do it at. Well, actually, maybe faster than that is to do -1 plus 2 times. Okay? Then we can transpose that to each one's on a row, and then we can do omega times rank 1. There's all your combos, sum them, find the index of the lowest. We need to name this thing now. We'll call it F for flips, I don't know. And then F indexed by that. Neg 1 is that. How many? Oh, not smallest. Smallest non-negative. Smallest non-negative. So that means basically somehow eliminating. So you got 0 less than, right? LT, because then it's F. LT compress F. Selected by index of the smallest of the sum compressed by LT. And that, yeah, okay. And then we can do the neg 1 equals and sum that up. Okay, so this solution works. You know, what do you want? Yeah, it works. So that's with 3, 10, 8, 12, 2, 10. If I just get my not right, escape. Sorry, what's this? 12, 2, 10. You flip one. Just more examples would be nice. We should get the result though, that's a good idea. So if we figure out which result it is, so this tells us it's 1, 1 minus 1, so we flip the 10. Oh, this one is not in agreement. This one says we flip the 10, but the answer here we're given is flip the 12. So is this right? It's 2 in S. Oh, hey, is that times? Why am I getting 20s? Why? Oh no, these are sums. Oh, sorry, yeah, I thought strictly positive. Apparently we're allowed zeros. Okay, so the fix there is literally just a matter of changing this less than to a less than or equal. Same result, confusingly, but now at least we're flipping the correct side. Flip the 12 rather than the 10. That's it. I'm going to save this in here. There are certainly things that could be cleaned up. He says, I'm not sure. What I'm thinking is, am I doing the best method for getting rid of the negative numbers? I think this is okay, to be honest. So I'm going to leave it there, or will I? What's in Subble? Yeah. So the plan now, basically, is to clean up the comments and to clean up the code a bit and think about my reasoning around each of the techniques. Maybe I will just get a consistent thing going with the word length. And this guy we can break up to be explained, especially since there are multiple inline assignments, which is clearly not great. So we've got flips, neg 1 plus 2 times 2 base power neg 1, neg 1 plus iota 2 to the power count, omega. All possible sign flips. Next, sums is the sum of omega times rank 1 flips. Then less than gets 0 less than or equal to, I guess we'll call it positive, plus VE, positive numbers. Okay, so we've got sums, compressed, pos compress sums, the index of the smallest one, the pos compress F, flips, selected by that. And this is, what's that? That's min flip. So, number of elements in omega to flip, resulting, the flip sign resulting in minimum positive, minimum non-negative sum. Yep. So once you've got the min flip, it's summing the number of minus ones. How many flips? Elements to flip. If this is the longest one, flip resulting in min non-negative sum. Mask, positive number mask, all sums. So, sums of all flips. I'll do. I think I'm fine with this solution. Then these guys I want to play with just a tiny bit more, just to get consistent. So words length. First of all, since we know it's just commas and dots in my lipsum, it's not there. Could we do that then? It just chooses one. So WL, keys all wrapped as nested defins. That sounds fun. Okay, let's fix that over here. So we're gonna have all of our options laid out. That. Oh no. Stupid autocomplete. Okay, that should work. Okay. That, yeah. Okay, and now the idea is we can go through our lipsum and even right does that. Set up all of our functions and we can compare them. Omega? Is that if I'm allowed to put no, okay, we're not allowed to just put oh what the hell? Rank error. Oh no, yeah, that's fine. I know. Okay, we don't need to do runtime already. Whoa, oh my god. I mean, I feel like I can assume the regex is correct. 30 take omega, neg 30 take omega. Okay, so let's say that lipsum gets neg 1 drop lipsum. And then we got space equals neg 10 take lipsum. Yeah, okay, so it doesn't end in a space, it ends in a word. And same at the beginning, it begins with words. So I feel like that'll make the whole thing more consistent across solutions. 4, 6, 4, 8, 4. So, the regex is keeping punctuation involved. Word characters, and is it punctuation? Regex, colon punct. Are we allowed that? So I was wondering about the P there. Inside defin. That's not it. Dot comma. 9. How's it longer? No, we said non-word characters. Allowed word or non-word characters from the beginning. Okay, that's one thing to do, huh? Let's take all the approaches. Take a piece in the middle. Like that. Okay. Yeah. Not so good an example. I thought it was all just... things like that might be plain funny. Like, regex calls that a word. I think that idea. Make your own one. Shorter, few words. Oh, a double space in there is probably not bad. Thing. Okay. Yeah. That's what's causing the big difference. Oh. So therefore, this guy... That's not what it is, sorry. It's that. This guy behaves similarly to this guy. Yep. Obviously. It's this guy that's wrong. We guess. Oh, that will count. Oh. we want to get rid of those characters anyway, meaning the efficiency. Okay, it might still be better to try and do an approach which doesn't generate intermediate nested arrays, and, you know, that being the main benefit. Oh, and also, and is also only concerned with cutting the beginning and end off. Oh, so it's more like alpha, omega, k, where alpha is comma space dot like that. Because then you can essentially do the same thing. You reckon? You can essentially do the whole exact same thing. Except you're going to put comma dot space on the left, call it alpha, blah 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 blah. Alphas in omegas. Right, U on WL2. And we're going to attach U there. Okay, and let's see. WL omega 2. Oops. And don't forget to make sure it counts. There we go. Yep. Oh yeah. Why does it? Hey. Now with them all giving the same result, we can finally. Are we allowed to ref like that? Not keen on that, is it? Okay. No, you're not allowed to reference omega in a runtime like that. You know, I guess it's not unexpected that the result, the runtime disparity is basically the same as when they were giving different results, because the reasoning's the exact same, right? And this second one, it probably isn't like hyper optimized either. It's just doing some basic steps to try and reduce the amount of computation and memory usage for a long input. The biggest difference being basically this glyph, so creating a whole bunch of intermediate nested arrays just to drop the first and last words off and then flatten the whole array again, which is another big assignment, another big memory allocation. And that's why these are the way they are. So, yep. That's it for the live coding bit. I'm going to take a little 5 minutes now, and then I'm going to maybe do a little short, concise, sort of going through my solutions thing. But if you enjoyed watching this, then thank you for watching. And if not, then who cares, you know? It's my channel, and Google hosts for free. So, yep, catch y'all later. Alright.